Good morning, all. Indeed, today we'll be discussing one more topic, that is network support for the multimedia. In fact, in the last class, we discussed in detail about the protocols for real-time conversational applications, wherein we discussed widely on two of the protocols called one is an RTP and another one is SIP. And we understood the significance of both the RTP and the SIP. RTP stands for Real-Time Transport Protocol. SIP stands for Session Initiation Protocol. Understanding this, now moving on to the last segment of this chapter discussion, that is network support for multimedia. You know, the network support for the communication of multimedia packets plays a very important role. The reason for that is the multimedia applications, more or less, they are called streamed protocols, wherein the packets are streamed and they are real-time transmission. So since it is a real-time transmission, obviously the packets will have a special treat in the network. Otherwise, the bigger delay or larger delay will lead to so much of issues in the network, and finally the packets may not be received at the destination in time, and hence there could be if a loss of packet, which the packet may not be able to accept at the receiving point, and it may have to be discarded, though it has been traveled a long distance from source to the destination. That's the reason the support of network for the multimedia should be a special one, and how it will be communicated in the media with the help of given network will be discussed in this discussion. Now, I think basically you know that more or less all the discussion what we made till now, the best effort technique is the one which is most oftenly used in the network communication. This best effort technique will be a challenge because it will be a very simple technique where in case of UDP, user datagram protocol, the packets are moved through the various part of the network to reach the destination at the earliest. Obviously, this will explain you that the packets are tried to push to the destination with the best effort, and there won't be any specific reason to say delay in the packets, because you know once the delay happens, the packet will be reaching the destination at various delay, and that may create the jitter. So let us look at the feature of this best effort. All traffic treated equally. This is the first question in case of the best effort. It won't distinguish the different packets differently. Rather, all packets will be treated equally, and every packet is tried to reach the destination at various level. And there won't be any guarantee in the delay. So that's the basic problem. You know, it won't give any guarantee that the packet will reach the destination at this particular point of time, or with a defined delay, and hence the definiteness of reaching the packet at the destination is not there. When it is indefinite, then the real-time application running becomes a challenge in this. Now you look at the mechanisms. What we use is the application layer will provide the support for this, and of course we'll be using the CDN and also overlay. I think earlier we have already discussed these two, CDN and overlay. The network will have its own virtual connectivity, and it is called overlay. And also the network level resources are being used effectively in this. And the very advantage of best effort technique is a very minimal complexity. So because there are no special treatment for any of the packets, so every packet will be equally considered and it is transmitted. The complexity in the process of transferring packet from source to destination is very less, and hence this can be deployed everywhere. Okay, so you need not look into any of the specific network. Rather, the data can be pushed into any of the network. It all depends on the quality of the network and the resources that are available. That will define how early the packet will reach the destination. With this introduction, we say that the best effort technique has got its own reason to transmit the packet at different delay. Now, actually, if you look at the real-time transmission with the multimedia applications, there are certain expectations. You see the expectation like low jitter and the low delay. It is always expected to have a very less jitter. Jitter I have already defined you. It will always explain you that it is the variation in the delay between one packet to the another packet. So obviously we have to have a very less amount of such variation in delay, and also the delay in each packet transmission should also be as minimum as possible, so that the packet will reach the destination in time to play it back at the receiving point. With limited link capacity, it is very difficult to avoid the packet loss. What is the difficulty in this kind of one best effort technique? The best effort technique will always be depend on the capacity of the link. If the capacity of the link is limited, then obviously the packet loss cannot be avoided. If the capacity of a link is very low compared to the actual requirement, obviously during the transmission, due to the buffering and queuing for a long delay, the packet might be lost. And because of loss in packet, there will be a cumulative action. You know, the once the packet loss happens, the retransmission is required. Once the retransmission starts, then definitely it will take much time to reach the destination, and total delay will be increased significantly. And hence we say that the limited capacity of the link leads to lot of packet loss, and ultimately this will degrade the quality of multimedia that is played on the other side. Now the question is how much bandwidth is to be provisioned. This is a biggest question for us. It's very difficult to say vaguely that how much bandwidth is required for the given application to run. If you go on increasing the bandwidth, there is an unlimited requirement. Okay, so that is why there is one new terminology, dimensioning the network. The very explanation of dimensioning the network is design of network topology to achieve the expected performance in end-to-end transmission of packet. So this concept is very clear. What is it telling is you have to design the topology of the network in such a way that it will give us an expected performance in end-to-end transmission of the packet. That is the basic need. So in designing that, what we do, a well-defined performance is expected. Okay, so obviously that is the very basic need of any of your real-time application. So what is that expected here is a support for the delay-sensitive traffic or conversational application. You mean delay-sensitive traffic or conversational applications are like I am talking to you. Okay, it is a conversational application, and any real-time application is more often called as a delay-sensitive traffic. If it is delayed too much, then it cannot be accepted or to playback. And hence we say such applications requiring the defined performance. Defined performance means the delay from source to destination for any given application for the given packet is fixed. You cannot go beyond the delay. If it is delayed further, probably it will not be played back. And then the expectation is to the end-to-end delay must be as minimum as possible. But for this, what is the expectation in the present day? We have two categories. Okay. The best effort technique is not being accepted, though it is cheaper and it has got a simple complexity. Complexity is too less, but it is not acceptable. What people are expecting is give service to my expectation and you charge for it. That's the reason there are two categories of expectation here, economic and organizational. In the economic, I think, the people will be ready to pay for it. Okay. And hence you have to look at service according to the payment or the cost of the communication. In the organizational effort, the things will be varying. See, organization will have the different network. When the packets are moving from one network to the another network, obviously, whether there will be a support from one network domain to the another network so that the communication can be done with an expected standard. So these two are the basic expectation. In order to make it possible, we have a different class of communication is possible. Okay, so we'll give different class of service. You can see here there are three different segments are identified. The first one we say it is the making best effort service. The second one is the differentiated service, and the third one is per connection quality of service. However, the best effort service is already discussed. All traffic is treated equally, and there is no as such guarantee of the service, and hence it is a soft one. And the mechanism, no network support is expected, and the complexity is minimal and deployed on every network. When it comes to the differentiated service, there will be a different class of traffic are identified, and the service will be given on that basis. And the guarantee is as good as the depend on the way you are expecting. And the mechanism that is being used in this case is either we say packet market, scheduling, or policing. Okay. And the complexity is but more than the best effort service, and it is called moderate or medium. And it can be deployed in not in all the network, but in some of the network it can be deployed. Then the last one is per connection quality of service. It is an high expectation. Per connection flow, we have to design the quality of service, and hence it will be using both the hard and soft what the guarantee in transmission. And the mechanism that are being used are one is packet marketing, scheduling, policing, and call admission techniques. Here the complexity is high. Obviously, you can remember one thing, as this mechanism is going to be more and more complex, the complexity of the network or communication will become more and more high. And it can be deployed in only little extent in some of the networks, not in all the network. Okay, I think that's what we told. Thus far, we making the best effort service. It is one size fits, and it is not an unexpected service. For alternative to this one, we have a multiple class of service, which we discussed in the previous slide, wherein we will partition the traffic into number of classes. This is very much important here. Okay, so it means that you are not interested in making the one single service. You do multiple type of service depending on the classes of input. So network treats the different class of traffic differently. Obviously, the expectation of different customer is different, and accordingly they are paying. That's the reason we have to give priority to the different people. So in a granularity, you can think that differential services among multiple classes, not among the individual connection. So we'll identify the different classes. Individual connection means one user, set of user. Okay. So class means number of set of users, but who are expecting the similar kind of service, they will be grouped together and it is created as class. For example, I can say video traffic is one class, and what we say the HTTP traffic, or otherwise we can say that text traffic is another kind. Okay, so these two can be identified as different classes. Class 1, class 2. The service to class 1 is different and service to class 2 is different. And hence it is said the way not among the individual connections, but individual classes. All these are called as a type of services, and we'll discuss that. So here you can see that the network will be like this, wherein two of the users are there, H1, H2, and H3 and H4. Assume that H1 wants to make some communication from H1 to H3, and H2 wants to make communication from H2 to H4, and there are two routers are identified. Okay, the two routers play an important role in defining the class of service. So the service class will vary from point of router to router. This we call as link. Okay, here it is expected link capacity is 1.5 Mbps. Okay, so now whatever the H1 and H2 will use, it all should be less than 1.5 Mbps. Okay, suppose assume that H1 is using 1 Mbps and H2 can use 0.5 Mbps, so that the total capacity should not exceed the 1.5 Mbps. Now let us go with the different scenario. The first scenario is mixed HTTP and VoIP communication. If this is the case, how exactly we have to come across the design of the network? HTTP communication is more or less, it is called the text communication. It expects the reliable communication, but it is not sensitive for the delay. Okay, it is called an elastic in nature. Okay, elastic means even delay is acceptable. If you send an email today, it is a text communication, and it may reach a little late also, no problem, but only thing what we expect is 100% reliable. Okay, but VoIP is non-elastic. So here it will not accept the bigger delay. It has to be transmitted in real time. Okay, if there are two categories of transmission, and then how your system will behave for that. In this example, 1 Mbps of VoIP, voice over internet protocol, and HTTP, both will share 1.5 Mbps link. Now you can see that it is making the transmission like this. Okay, and here the another transmission is going on from this point to this point. Okay, this is an HTTP communication. This is an VoIP communication. Let us assume that when they are transmitting, this is transmitting at a 1 Mbps and this is transmitting at a speed of 0.5 Mbps. So that this 1.5 Mbps is really acceptable. But all of a sudden, this Vivo IP has a bursty transmission. Bursty means, you remember one thing, bursty is nothing but a sudden release of packet. Sudden release of packets. Sudden release means heavy packets are released at some point. I'm speaking to you now. The moment I am speaking, it will burst the packet. Moment I am quiet, it will reduce the number of packets that are transmitted. So that is why it is called bursty. Whenever a bursty happens, this 1 Mbps may become 1.5 Mbps suddenly. In that case, you see this. The HTTP is also transmitting 0.5 Mbps, but it is transmitting 1.5 Mbps at some point of time. So total requirement becomes 2 Mbps, but the link has capacity of only 1.5 Mbps. So this becomes a problem in this. Okay, though we have been differentiated the classes of transmission. So, but because of bursty in nature, there might be a chance of again a problem in the network. So the solution for that is we go for a marking of the packet. Okay, so this packet should be totally distinguished from this packet, and we are supposed to give solution for this. For quality of service guarantee, what if application misbehaves, like sending a higher rate of transmission than the declared one? So for this, it requires that the bandwidth restriction is the only solution. So what we do is we restrict all the packets that are moving from H1 to H3. H1 to H3 are restricted to only 1 Mbps. And from H2 to H4, we will allocate only 0.5 Mbps. So if this is the case, so there cannot be an overlapping of the bandwidth, and hence each one will have a promised service to the destination. But the question here is, how the router will identify the H1 traffic and H2 traffic? This is the question. So for this, what we have to do is marking is very, very essential. We have to mark all the packets that are coming from the H1, so that let us say they are marked with a special marking of 1. All packets that are moving are start with a numbering 1. All packets that are moving from H2 are marked from with a starting marking of 2. Okay, all the packets with 1 will be treated with 1 Mbps transmission. All the packets with 2 marking will be treated with 0.5 Mbps transmission, and hence it is easy to distinguish the transmission speed, and they can give in service according to this one. So this requires both the marking and policing. So what is the policy in the system? So we have to give the support for the required bandwidth, and hence we say the policy says that the communication between H1 H3 must be given only 1 Mbps, and the communication between H2 to H4 should be supported with 0.5 Mbps. Okay, so this is what we say protection of or isolation of the class from one another. It means by isolating each class in the network logically will help you to manage the bandwidth for each of these communication, so that the communication is more effective and the throughput of such communication will be better. Now the question is, even if you do that one, there are possibilities that when you are transmitting the packets in this way and in this way, there are occasion, this I have told 1 Mbps is the requirement, and here it is 0.5 Mbps. Okay, so now suppose you assume that at some point of time this 1 Mbps may become 0.5. Okay, and this is also 0.5. What happens? So the effective utilization is 1 Mbps. Another half Mbps is being lost. Okay, so this becomes a greater question in this. Okay, always you want to see that uh, by doing this policing and making the marking and all, we are trying to improve the quality of service, but at the same time the question that resources are not utilized effectively. Okay, so we call it as use it or lose it. So that should not be happened. Okay, so we have to use the resource in an effective way. Okay, so for that, what is the only the provision is you have to see that whenever one of the resource is not being used effectively, the other user should be allowed to use it. Okay, suppose in the next minute, let us assume that H2 is not transmitting any data to H4. Okay, H2 is not transmitting any data to H4. The bandwidth that is being consumed is 0. But whereas here it is sending data at the rate of 1.5 Mbps. So then what is the problem? It is restricted to 1 Mbps. This still have a 0.5 Mbps, but it is not transmitting any data. So now what could be done? So if you want to give a chance that this link will use from H1 to H3, it will use the 1.5 Mbps fully at that point of time. Then it is the better resource utilization. So this is again has to be given a provision. So all these are the some of the possibilities that can be performed with this. So now till now we understood a few things like the basic technique was best effort technique, but this technique is not sufficient for the treatment of a different class of services. That's why we need to give some priorities to some class of packets. That is done by means of marking the packets and transmitting with some policy making. Okay, so a particular class of packets might have given more bandwidth for a transmission, and some other packets might be given little bandwidth according to the requirement. Now, how do you do the scheduling and policing? That is the question. For this, there are different algorithms are proposed. Let us discuss a few algorithms on this. How to send the packet at treat the packet at the router, and how it has to be maintained in the buffer, and how it has to be given service to transmit to the next level. One of the scheduling algorithm or technique is known as the first in first out scheduling, which is the most basic technique. Here it's very simple. The packet that has arrived first will be transmitted first. That packet that arrives later will be transmitted later. I think in cinema ticket queue, what do you say? The queue that is called uh, the first in first out, because who has entered the queue first, he will be going out first. Okay, so similarly the first arrived packet to the queue will be transmitted or delivered first. Okay, next arrived next, like this. The third one will receive the delivery the third level. So it is a simple kind of an technique. And so here the discard policy is also required. What is discard policy? Suppose if the buffer size is 10 packet and 11 packets are arrived, what to do? You cannot give a service. Okay, one packet will be discarded. which packet to be discarded is the question. So the tail drop we say, it means that the one which is at the last in the tail, so that will be discarded from the queue, and the rest will be given service. The priority the removing the packet from the queue is on priority basis. First come will be given first service, second come will be given second service, and third come will be given third service. There are occasions wherein even the other possibilities are there. Random drop is also a case, but it is rarely occurs in the first in first out. Now, due to the first in first out, what is the possibility is there might not be a priority given to some of the application. You are treated all packets equally, but that is not the true scenario in the practical case. So what actually happens is there might be a real-time application which is required a faster delivery of the packet. There might be a non-elastic data like email, text, and all, which can be accepted some delay and make the transmission. So now how you distinguish these traffic and give the service? For this, we have the priority scheduling technique. In this priority scheduling technique, it will send highest priority queued packet first. You see, firstly, you have to segregate the two prioritized class of queues. This is class 1. Let us assume class 2 service packets. Already we have told that each of these packet is marked. So here you can see the class 2 is marked with the green color, class 1 with the red color. The moment it arrives to the router, so they will be segregated and they will be put in a different queue. So class 1 queue is different, class 2 queue is different. What exactly this priority scheduling does? It will always give priority to the class 1 packets. First priority is given. So once all the packets are serviced in this Q1, then the packets of Q2 will be serviced. Okay, so this is the basic structure of this prioritized queue. But you see that how exactly it will work for it, we can see that. At this point, you can see the packet 1 has arrived with class 1. Packet 2 is class 2. Packet 3 is class 1. Okay, and packet 1 is transmitted, and then packet 2 is not delivered, though it is already available at the, it has been arrived and it is available in the queue. It will not be delivered. Rather, packet 3 is delivered. Why? Because packet 1 and 3 are class 1 packets. They have got higher priority than class 2, that is packet 2, and hence these two will be given service. Only then the class 2 packet, that is 2, will be given service. Okay, but in the meantime, one more packet has arrived, that is fourth packet, whose class is 2, and sorry, class is 1, and obviously it has got higher priority. Next, the 4 is transmitted. Next, fifth one has arrived. Again, it is class 2, and no other class 1 packet, so that class 2 packet is given service. The meaning of this one is, here you can see the order of transmission. The higher priority, that is class 1 packets, will be transmitted first, and then only if there are no class 1 packets, then only class 2 packets will be transmitted. But what is the problem you can see here? If suppose always class 1 packets are arriving continuously, and class 2 packets arrived will be in the queue only, they never be given service. It is called starving. There might be a starving happens in class 2 packet because of high prioritized packets arrival. So this is the basic problem in this case. For this, what they do is they will give an opportunity called as round robin scheduling. In case of round robin, what we do is if there are two different queues, then this is one queue, this is another queue. Okay. Both the queues are given an equal opportunity like this. Okay. First, it will service Q1 for one packet and then Q2 one packet. Again, Q1 one packet, Q2 second packet, Q1 third packet, Q3 fourth packet, like this. So one after the other, the service will be done. It is done in cyclic scan class queue, sending one complete packet from each class if available. Here also there is an issue. You can see that the packet 1 has arrived, it has been transmitted. Packet 2 has arrived, but 2 and 3 both have arrived, but 3 is class 2. It has given priority to the class 2 and it will be transmitted, okay, after class 1. And then again, class 1 packet 2 is there, class 1 packet 4 is there. Both are transmitted, okay. And you can see that fifth packet is also transmitted here. Now, again, there is an issue here is that by doing this, you are considered all the classes equally, because class 1 and class 2 are transmitted considered equally. This must be 2 only. Yeah, this must be 2. 1, 3, 2, 4, and 5. Right. So both will be considered equally. An equal priority is given, but again, it is not on the basis of class priority. So that is why we have to go for class priority. For that reason, we will take up another technique, that is scheduling technique. It is called as weighted fair queuing. So in the weighted fair queuing, the starving can be overcome. Okay, it has overcome. So what will be given is weight will be given each of these what we say the each of these queues, and hence the transmission can be done on the basis of the weights that are given to these queues. Weight 1, weight 2, and weight 3 are there. Okay, so we can give the priority like this. Weight 1 has got highest priority. I'm sorry. Let me select the pen. Weight 1 has got highest priority. Weight 2 has got next priority, and weight 3 has got next priority. So if this is the case, then the service is given with the priority to the Q1. Okay, all the packets of Q1 will be transmitted first. Then all the packets of Q2 with weight 2 will be transmitted. Then all the packets with Q3 with weight 3 are transmitted. This weight can be varied. This may be considered in different way. W1 has got a higher priority than W3, but W3 has got higher priority than W2. That can also be done. Or again, the reverse of this. Okay, W3 has got highest priority, W2 next, W1 next. So likewise, the different priorities are adopted. So now what we are doing is we are considering the weight of each of these Q plus the round robin technique is used. So both will help us to overcome this starving, and hence the class operation is also, or class service is also possible. So this is because of this reason we can say that there is an improvised performance in the system. So with this, I will conclude this session here. However, we can discuss the next part in the next class. Thank you.